Hello there. My name is Dylan Finn, and I'm here with my partner Alan, and we are here to discuss our second update on our EE327 design project, which is called iPlant. So a brief project description here. The idea is to have a battery-powered probe that we kind of stick into the ground right next to the plant, and it's created to monitor outside variables that are important to the plant's health, like temperature, humidity, soil moisture, and light intensity. And then the idea is to then send those to a server every hour and be able to view them on a mobile device, and then also compare them to a database of common houseplants that have those ideal values for that specific plant for the best growth potential. So here's where we currently stand in the design process. I'm going to talk about the code for the sensors, and I'll let Alon take over the software part. So we have three current sensors, one that measures temperature and humidity, one that's simply just a photo resistor that measures light intensity, and then one that is a soil moisture sensor. And we've been able to write code for all three of those and read data from the ESP to our computers, which is essentially the backbone of our project. And I'll let Alon take over the software part.
Yeah, so the side of the web server, we've done some work. First of all, we were able to send data from the ESP32 to a Tornado web server using HTTP requests. And this data that we sent was in a form of a string, which could be a representation of a JSON file. And another thing that we did on the side, it was making sure that we can populate a database on the Tornado web server. So what we did, we created an SQ, we created a database using the SQLite library, and using the Tornado framework, we were able to populate the database, but then also query the data from the database and display it on a web page. So with these three different aspects of our project, meaning the reading data from those sensors, sending the data from ESP32 to the web server, and populating that data into a database and displaying the result to the user. So we have all those three different steps working separately. So the next goal is to sort of connect everything together so that we can have an initial functional prototype that can read data from the soil, and then on the other hand, have the client be able to read the real-time data on a web page. So going to the next slide. Throughout this project, we learned so much about web design. Essentially, we had to go through the basics of HTML, CSS, JavaScript, but then also learn about Tornado web servers and how to interface that with SQLite database.
So we did interview one more person after the last presentation, and he actually had a lot of pretty good ideas and thoughts on our project. So the first was that his first thought was that he wanted to be able to use the probe outside, and if we could weatherproof it, to rain in extreme temperatures, then we should. It definitely would add some versatility to our project, and we'd be able to use it in many different conditions. And then on top of that, he said that if we were able to use it outside, we could turn it into a sort of regulatory device for the FDA or something, who would put it by company factories who are known to pour chemicals into rivers or whatnot, and then they can measure some pollutants from those measurables. A couple other ideas he had was a simple watering system with just a motor and a pipe. And a camera to monitor the plant while you're not with the plant or away on vacation or something. You can make sure it's not dying. And a push notification system when a measurable such as temperature or soil moisture is way too far off its ideal value. And then a couple questions we have for our audience. How long should you guys think that we should have the probe last before you have to change the battery? And should we even use rechargeable batteries at a significantly higher cost if the probe may last over a year anyway? Because as we mentioned in our previous slide or our previous presentation, we do plan to use the ESP32 deep sleep mode with this project, which uses, I believe, around 0.15 milliamps max at a time, all the way down to like 10 microamps, I believe, which would make it last for a very long time, even with something like AA batteries over a year, I believe. And then our other question is general data analysis techniques. What are some good platforms for some data analysis? And that is our presentation. Thank you for watching.
Wow, that was great.
Yeah. Wait.